Okay, good morning. Yesterday we looked at tangent theorems, and the first theorem we looked at, the very first one is that if a line is drawn from the center of a circle to touch the point of to touch a tangent, we say that the angle that they make to each other is angle 90, and then we solve some questions. And then the second theorem is that if a tangent to a circle, if we draw a tangent from an external point to a circle, we say that the tangents must be equal. So today we are going to look at another theorem, which will be the last theorem in this session, and then that will end circle geometry. The theorem states that the angle that a chord makes with the tangent is equals the angle in the alternate segment. Okay, this is what I mean. If this, let me try to just put it here. If this is a circle, here is a chord. Sorry, I think this is kind of bad. This is a circle. Here is a chord. Let's say here is a tangent. Here is a tangent. If this is the angle in question, this other side will be the alternate segment. Okay, if we have another circle like this, let's say here is the tangent, and this is a chord to this circle. If this is the angle in question, this other side becomes the alternate segment. So what this term is saying that the angle that the chord makes with the tangent equals the angle in the alternate segment. So this is the diagram representation of the theorem. Here is a circle. Let's say this is a tangent that touches the circle at this very point. If this is a chord, and let's say there is an angle built on this chord, so this angle theta, according to this theorem, equals this angle, which is the angle in the alternate segment. As I explained earlier, if this is the angle in question, this other side becomes the alternate segment. So if this is theta, here will be theta. So the theorem has been diagrammatized in this way. The angle that a chord makes with the tangent equals the angle in the alternate segment. Here is a chord, here is the tangent. Okay? Here is a chord, here is a tangent, and this equals this angle at this other side. So let's quickly solve, look at an exercise on these notes. Okay, now Ty is a tangent to the circle TVS. This is a circle. If SVT equals 48 degree, angle SVT equals 48 degree. This angle, this very angle is 48, and VS equals ST. Obviously, this sign simply means this line and this line are equal. What is VTY? VTY. So we are asked to find this angle, this very angle. So how do we do that? Okay, so how do we do this? So the one thing about circle geometry is that you just need to be to think radically. There are several ways of doing it. So the method I'm about to use might not be the only one actually. So but based on what I can see now, so we know that this is an isosceles triangle. Obviously, this is an isosceles triangle. Isosceles triangle because two sides of this triangle are equal. And then because this is an isosceles triangle, there is a fact that the base angle of an isosceles triangle must be the same. Abina. So meaning that SVT, this angle must be equal to STV, this very angle, because this is the base angle of this isosceles triangle. So this is the fact. So SVT equals SVT must be equals to STV, which equals to what? 48 degree. So here is 48 degree. Now what do we do? Remember, we are asked to find this angle, but we are so sure that this angle must be equal to this angle. So if I can get this angle, I've already gotten this. Okay, so now that we have that, so the reason SVT equals STV equals 48 degree, the reason is that base angle of an isosceles triangle, okay, now so in order to find VST, we use the fact that the sum of angle in a triangle is what? 180 degree, and VST is equal to VTY, which is what they asked us to find. So now let's try to use that fact that the sum of angle in a triangle equals 180. So VST now, VST, which is this angle, VST is equal to VST plus 48 degree plus 48 degree must be equal to 180. The reason is that sum of angle in a triangle, sum to 180. So that gives us makes us to have XTV to be equal to 180 minus 48 minus 48. So this will be equal to, so 48 minus 48 should be 96, if I'm correct, and then 180 minus 96 should be 84. I think I'm correct. You can check that out. Okay, so VST equals 84, and then we know that VST equals VTY, which equals to 84. So we have successfully find the angle VTY they asked us to find in this question. I hope that is clear. If that is not clear, you can send a message. Okay, so now let's try to look at another example. I hope this is very, very clear. Okay, now let's look at this example. Okay, I said in the diagram below, TS is a tangent. This line is a tangent to the circle PQRS. This is a circle PQRS. I said if PR equals PS, PR equals PS. Obviously, this line, this symbol means this side and this side are equal, and PQR is 117 degree. Calculate RST. Okay, so you are asked to find this angle. But based on the theorem, the theorem we just saw now, the theorem 3 of tangents, this very theorem says that this angle equals to the angle in the alternate segment. So meaning that this angle equals this angle, because this is the angle, if this is a chord, the angle built on this chord is this very one. So if this is theta, here must be theta also, based on the theorem we just looked at, that the angle that a chord makes with the tangent equals the angle in the alternate segment. But now, so how do we do this? Solution. How do we do this? Okay, so as I said earlier, you must be a radical thinker when it comes to solving circle theorem. You must be a radical thinker. So how do we go about this? Looking at this, when you see before now we've talked about a theorem that talks about cyclic quadrilateral. So obviously this diagram is a cyclic quadrilateral because it touches the circle at 4 different edges. So this makes it a cyclic quadrilateral. And then there is a fact we know about a cyclic quadrilateral, that the opposite angles sum up to 180 degree. So we can use the fact that this angle plus this angle must be equal to 180 from cyclic quadrilateral theorem that we looked at. Okay, so that tells us that PQR plus PSR equals 180 degree. Reason: cyclic quadrilateral. That's the reason. So meaning that PSR will be equal to 180 degree minus PQR, which equals to 180 degree. We know that PQR is 117 degree. So 117 minus 180 should be that should be 63, if I'm not mistaken. 180 degree minus 117 degree should be 63 degree. So we now know that PSR equals 63 degree. So now if this is 63 degree, this is 63 degree, but that is not what we are looking for. We are actually looking for this theta. We name it theta. We are looking for theta. But one thing we know is that theta and this very angle are the same. Theta and this very angle are the same. So what do we do? Okay, so one thing to do is that look at this triangle PRS. Triangle PRS is an isosceles triangle. So when you see an isosceles triangle, you must know that it's an isosceles triangle. So when you know one side of an isosceles triangle, you can actually know when you know the angle, one angle in an isosceles triangle, you can know all the other side. So because we know this 63 degree, this of course must be 63 degree. What's the reason? The reason is that base angle of an isosceles triangle must be equal. Okay, so meaning that PRS must be equal to 63 degree. What's the reason? Base angle of an isosceles triangle. Base angle of an isosceles triangle. So we know this to be 63, here to be 63. So obviously we can find theta. Okay, so how do we find theta? We know that the sum of angle in a triangle sum to 180. The sum of angle in a triangle is 180. So meaning that theta plus 63 degree equals 180 degree. So this is theta plus 63 plus 63, that should be 126 degree, I think, equals 180 degree. So theta must be equal to 180 degree minus 126 degree. So this should be equal to that should be 54, I guess. 54 degree. That should be 54 degree. So theta, we know that of course theta equals to RST, angle RST, which equals to 54 degree. So we have successfully find the angle they are asked us to find, RSTV. So as you can see, this theorem is very, very simple, and most of the theorems, most of the questions you will see, you have to use 2 or 3 theorems or 4 or more than that, depending on how the question is structured. Okay, so you must be able to carry all the theorems you have learned so far along with you, especially when you are dealing with tangents. Okay, so this will end our class. So the end. Thanks for watching.